All right, today is 6/8/2025. My name is Christian Aspinall, and this is the Module 5 project for collections. And this project, our objective was to demonstrate the use of collection framework and the collection interface, right? So this program is going to prompt the user to enter 8 unique single words for entries. And with these entries, the program is then going to use a various sort of methods to manipulate the created list that we'll have. The user will also be prompted a second time to enter a word for a word to search for within the list. And so let's start with our imports. All right. So we have an ArrayList import, and so we're using the ArrayList string to store user inputs. This comes from the ctl package, and without it, the compiler doesn't know what ArrayList is going to be. So if we go over here to ArrayList, we're using it in two situations. We're using it in our main when we instantiate a new ArrayList, and when we're converting an ArrayList back to a list. We'll get to that, right? We have a scanner, and scanner needs to be imported because our user is going to input information from the keyboard, and the program can't accept. It won't understand what scanner is without this import, and the user won't be able to do that. We're then getting collections, and we need collections for our static methods such as sorting, shuffling, and the two static methods of min max that we'll be using in this demonstration. So this obviously this is different from our collection interface. We are simply implementing static methods as needed. The comparator import is going to be used to create a custom comparator for sorting the list by string when we get to that. And finally, we're importing arrays because we're going to convert between arrays and lists, like using the methods asList method and the toString method. So let's get started with our unique word list app. So we're instantiating a new array list, a new list of strings called words. So this new array list, right, is going to hold these string objects. And then we're instantiating a new scanner object that is going to take in input from the users. We're gonna prompt the user, enter 8 unique single word entries. Duplicates will be ignored, and they're case insensitive, meaning that one is capital, one is lowercase. Our program is going to factor that in all the methods that we do. So, step 1, we're going to create a list. So we start with a while loop. So as long as there are less than 8 items in our word list, so while words.size is less than 8, we're going to print out, we're going to enter word number, adding the word size plus 1, which is basically each new entry will increment the number and show the user which word they are on, right? We capture the string as an input from the user, accepting their input. Then we have a boolean is duplicate equals false. So we're assuming that the input is not a duplicate, right? So for each loop, in this for loop, we're going to loop through each word in the list of words, right? And if the word is a duplicate, it's going to come out true, and then we're going to break the loop. And if it is a duplicate, the duplicate entry is going to be detected, and then we're going to ask them to enter a word, right? Else, we're going to append the input from the user into the word list. So let's see that in action. So enter word 1, right? We're on word 1. Why is it word 1? Because our word size is 0, right? We have no words appended to our list. So it's just going +1. This is our first entry. So since there's going up to 8, I'm opting to do the planets. So we're going to do Mercury Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. All of these guys in our solar system. So, let's look at here. So we made our list, right? So now our second task was to print the list using an enhanced for loop. So we have our little header, the words in the list, and for each word in our words list, we're looping through each word in the words list. We're going to print out that word, right? So our first word was Mercury. It prints Mercury. Then it prints Venus, Earth, Mars, Jupiter, etc. We have our list printed out. So let's get the total number of entries. So words.size, a method basically telling us how many items are in that list. And we're just printing that out. So there's 8. Exactly, we entered 8 words. So now we're going to find the longest and shortest entries. So we're going to create these two string variables, longest and shortest. And we're just going to have these, we're just going to set them as reference points for these next 4 loops that we're making. Right, so for each word in words in our list, we're looping through each and every word. We're checking if the word's length is greater than the longest length. So let's take, for instance, our first one is going to be Mercury, right? That's 1, 2, 3, 4, 5, 6, 7 characters, right? At the moment, what is longest right now? It's going to be 0 because we capture it as a 0 value. So now we're comparing, is Mercury greater than 0? It is. So longest is going to capture that word in the array, right? In this situation, it'll continue to loop, and we'll see Venus. Well, it'll actually also do this, I'm sorry. We're going to also check the length of the word and see if it's less than our shortest. The length of the word is shorter than the current length of the word of shortest, right? So we're going to capture our shortest word. And right now it's set to Mercury, right? Because it was the only word we've gotten so far. But Venus, interestingly enough, is less than Mercury, right? So when Venus gets passed in here, is Venus going to be longer than Mercury? No, our longest word is still going to stay and be captured as Mercury, but it is shorter than our shortest word of Mercury. Venus has less characters, so it'll capture that, right? So as you can see, this will iterate through. Mercury is in fact our longest word, and our shortest entry is going to be Mars with only 4 characters. So we iterate through all of these and we capture them. So now we're going to sort our list alphabetically. We're going to print out this header as it comes out here, and then we're going to call our collections.sort words. So we're calling that static method. That's why we imported collections. We're implementing the static method of sort and we're passing in our list of words. So calling the sort method to sort words alphabetically. And then to do that, we're going to for loop for every word in words. We're going to print out each word after it's been sorted, right? So the sort Earth with an E, J comes after E, M comes after J. Notice how Mars and Mercury are here. Mars starts with an A, so it's sorted before Mercury. Makes sense. N follows after M, etc., etc., etc. Right? So this is our sorted alphabetically list. Now, we're going to sort our list by number of characters in each string entered, from longest to shortest. Okay? So, we use words.sort. And our new comparator string, we're importing comparator also. right? Necessary. This is where it's here for. So we're sorting the words list using a custom rule to create an anonymous class that implements the comparator string interface, right? And we're using override because we're implementing an interface method, right? So we need to override this. So our public.inCompare, we're comparing the first string to the second string, comparing two items in the array, and then we're going to return integer.compare s2 length 1, length, right? So if this were inversed, s1 and s2, it would actually return an ascending order, right? So as you can see, Jupiter and Mercury, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. So they both have the same amount of, and Neptune, and Neptune. All three of these have 7 characters, so they're all on top, followed by Saturn, Uranus, Mars, etc. Now, an interesting thing to note is that we have our longest entry is Mercury. Why is it Mercury? Because Mercury was the first item in the list initially when we instantiated our list and captured it. Right? We're not factoring in that the alphabetical. We're not factoring in that where their position is in the alphabet. It's just since this came first, and it's not technically equal to them. Yeah, it's like Mercury, Jupiter, or Neptune are not longer than Mercury, so Mercury stays the longest, even though we have Jupiter here coming into being the longest. So then we header and sorted list. Yeah, we did this. Use the shuffle method to output the shuffled list. All right. So collections.shuffle. We are calling our static method again, shuffle from collections, and we're passing in our words list again. So we are just shuffling the elements within our list, and that is our sort. That is technically sorting. So making another for loop for every word in our words after it's been shuffled. We're going to print out each word. And now this is our list sorted. After longest to shortest, you see, we did our longest to shortest. Now we have it shuffled. Uranus is on top. Mars is here. This is just random. This is from our shuffle method. Now we're going to ask the user to search list and outputs where it was found. So now we're here. So now the program's asking me to enter a word to search for, right? So just before I do this, let's walk through this. We're entering a word to search for. So this search word, we're capturing whatever this user inputs as a string. So I'm going to input Earth. So we're going to instantiate a Boolean, a found variable that is set to false. Right now we're going to loop through each index in the word list and while incrementing through it. Right? So if the word input by the user matches a word in the list, we're going to print out the word right here. We're going to capture found as true. We're going to change our Boolean to true since we found the word, and we're going to end the unnecessary looping. We found it. So let's enter this. Well, first let's not enter this. So if it's not found, we're going to get this error. Well, not an error, but we're going to get the system that the search word was not found in the list. So let's put Earths. Earths was not found in the list. Right? So let's just let's run this again. I just wanted to show you that. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Neptune, Uranus, and now we're going to search for Earth. Oh, I misspelled it again. Whoops. Let's play it again. Mercury, Venus, Earth, Mars, Jupiter, Neptune, Uranus, Saturn, Earth. We're entering a word search for Earth. So Earth was found at index 2. So after it's been shuffled, we can look here on this list. Why is it 2? Because Jupiter is at index 0, Uranus is at index 1, and then Earth is at index 2. So then we do that, and that's done. So these are the two, so now we need to implement 2 static methods from the collections class, and these are pretty simple. So I opted to use min and max. And so when you use min on string, you're actually just finding when you're finding the smallest element in a word list on string, it's based on alphabetical order. So based on alphabetical order, Earth, the E comes before any of the other words used, first letters of any of the words. So Earth is going to be returned as our min, and Venus alphabetically is the last word among all these planets. So Venus is going to be returned and print out. So now we're going to convert our list to an array. So we're instantiating a new array, a new string of arrays called word array, and we're using the method toArray new string 0, right? So we are putting this method onto words to convert it to an array, and we're capturing that as word array. So then we're printing out a list converted to array, and we're running our for loop again, right? For every word in our word array here, we're printing out the word. So there's our list converted to an array. Jupiter, Earth, Uranus, Earth, etc. We have them all. Then we're converting it back to a list. So here, we're passing in the string array, word array, to convert the array into a list, as a list, using this method from arrays. And then we wrap it into a resizable array list, independent of the array, right? This new list. Then we are converting it. Then we are running our for loop, our string word new list. We're running through this new list that we just made, and we're printing out each word within that list. And then we're doing that, converted after a list, and here it is. There it is. And then we're closing our scanner, as a good person should. Don't leave it open. And just up here are my sources and my comments on collections for the course. So yeah, thank you for watching.